So, sorry about technical details. I don't know how you managed, but some of you made it in here before me. For starters, I have to say that on top of everything that might happen with the overhead projector, anything's possible here for what I see, but there might also be some typical live problems, because I think I have 14 slides, no more, and the rest of the time we will be just coding. So it is quite probable that things fail or crash, but even if it crashed, I will code, I will write and explain why everything is like that, and it'll be a bit more interactive. I think I've backed some 30 minutes for different fails. I don't know what's the format here, I didn't see them, but if you have any questions as we go, you can ask whatever you want. I will open the slides. I've had some slides here because they told me I had to upload something, but if not, nothing would be here. Then the headline is a bit weird. I don't have much to say, to be true. And this is the trenches, because we will be writing code, and so this is more hacking style. I'm Danny Crow. If you try to find me, some span about me, I've just been introduced, and I have expertise in hacking, secure coding, customized hacking, source code audit, code security, auditing for companies and public institutions, and we also develop customized tools and monitoring and everything else, always customer requested. I work in Navaja Negra, in Madrid, and that's it, right? Every now and then I like enjoying my life. That's a vice of mine. Hope you don't mind, but I will move around because I need to have both screens, otherwise I will don't know what I'm saying. I'll explain security, and yet I'll be focusing on networks. I know that you had Rafa and Pablo yesterday in the room explaining SCAPI, but they were focusing on IPv6, if I'm not mistaken. So I'll explain SCAPI on network hacking, and then we'll have prompts, SCAPI, and how we can build up tools with that little by little, and then I will show you how to develop a small tool, a bit easy, where we will have a force root directory, some WFUF or something of the kind, but using the WFUF or similar elements and adding a great deal of intel, meaning that it can detect error sites, prompt-to-prompt comparison, the div and matching ratio. That way it'll be a bit more interesting, otherwise it was not enough. And then everything else. Let me show you this. So packet creation, forwarding, pickup, sniffing, flooding and fuzzing. I guess this ring a bell. If not, let me know. No insults unless they are very ingenious. And as I said, I have to be halfway in between these two screens. Visible, like this, right? Are you familiar with SCAPI? Raise your hands. SCAPI, SCAPI, SCAPI. Good. Have you ever used it for anything but just forwarding a packet or traffic analysis, pickup? I mean, it's just for in order to understand where you are. So it's mid, advanced knowledge. Please raise your hands. Raise your hands. Okay, well, we'll see it as we go. As you know, it has to be run on root, otherwise it will tell you that no traffic can be sniffed. So, welcome to SCAPI. So, not comfortable. If you are not familiar with the Scapy, just briefly, and even, this does not exist, it's a function of my own. Well, actually this is part of the framework, and it's console level and prompt delete and the system console deletion. Not much, but it's useful though. This is a framework, a tool with which we can have tools generated, even binary. But what's good about it is that it's so simplified, it's so intuitive or user-friendly, because it goes all the way down to the protocol layer. I guess you're familiar with the TCP, TCP/IP and other protocols. Oh wait, I need to mute myself. So, Scapy, when we load it, it has many layers. In a nutshell, that would be a protocol. The IP protocol is a layer, TCP is another layer, but then DNS is split into 2 layers, but they both work together, so actually they cannot be taken apart. Why am I saying this? Because we will be saying layers all the time, and we will stack and destack in a given way, playing around with them, and well, for a few other purposes. If you're familiar with Scapy, you might get bored, but I need other people to follow what I'm saying here. We will have 2 very simple packets, ICMP and TCP connection to a port, just like that. Look, this is simple. This is the prompt, just the same as on Python when you run it. The only difference is that it's doped, because it has different colors and functions and libraries and layers in order not to have front and imports. It's easy to use. But if it's not been loaded before running, it means that it's not being used often, according to the authors. But IP, TCP, it's all pre-loaded. And why do I say that? Because this is just like Python. On Python, you know, this is a variable that says IMCP equals 1. That's it. Simple as that. Okay, first variable, and I get an error. Hi world, hello world. How do we build a basic packet? Well, you know, IP, Ethernet, but we will use layer 3. Then we have the ICMP layer. We would generate the protocol stack little by little. See how intuitive this is? First IP layer, second it would be an ICMP layer. If I stay away from your... okay, I'll make it difficult for you, right? But I have trouble staying seated for a long time, I have to say. So, check this out. Open and close parentheses. Why? Because layers are just types of programming for Python, and it's just pure syntaxes, that's all. So check this out. Then when you add the same variable, and that's what we get. This is an IP packet, this is the protocol, and the next one is ICMP. Not much to it, right? And now let's play around. So I only get limited information here. Well, Scapy works its magic, and the packets is that it generates, apart from layers, it has embedded methods that give you additional information. And here what we have is we see the packet as it will be sent to the net. Even though there are many parameters that we have not specified, they come by default. And what's funny here is that those are the source and destination IPs. If we don't say anything else, in order not to mess it up, it takes localhost both for source and destination. Same goes for ICMP. It has this request, which is a ping. Not much to it. But then, how would we know what options do we have in each header? Scapy has some help functions, such as this one, ls. On the left side you get the function rather the parameter name. This column here says the type and then the defect or predetermined values. Easy so far, isn't it? And so we go back to our ICMP packet, and we have show 2. The difference compared to show 1 is that we see the packet as it will be sent to the network. What's the difference without 2? Because checksum and others that are the ones that are calculated right before you forward it, because it's packet dependent. So with show you don't see it, but with show 2 you have it pre-calculated. That and the protocol type and all checksums as well. So we have the ICMP packet created and we send it to the local host. And I'm worried that I might be connected to the network because there could be network tests going on. Let's hope it is securized, that network. Scapy gives us 2 functions where we can send without a reply or send and reply. Send and send P is one works on layer 3 and one layer 2. One is from IP above, it's enough. SP, that would be layer number 2, and source destination need to be specified. Since we have not, that's it. We say send that packet wherever it has to go. No mystery, right? Not much more to it. And this way we create a packet, little packet. Now let's have another packet created with parameters. You see, we haven't said anything specific, but let's say something at the very least. Here, it's not just the IP. If you add a domain, there is also resolution there. See this ICMP? See how it says net, so it'll solve it. And you send it just the same way. Now that we are familiar with Skype, we know how it works. Let's see a few more functions. This one is just for sending, but we need another one for sending and receiving, because if we want to have a non-reply response or communication such as flooding, well, it's okay, but that's not the common way. You need to send and receive, because otherwise you need to send the packet, have this sniff, match information, and that's quite not easy to use. And that's why we have SR1, send and receive, and that's the way it works. It has 3 options, but SR1 is the most common one. It sends a packet, and the first reply packet is the only one that I see, the only one that you need to gather. Why do I say the only one? Because when you send a packet, depending on what you're sending, you can get many replies. Oh, let's say we are having a phishing, a spoofing, then we will have the reply from all the local hosts or the network hosts. So that's the same as the send function. We got 2 packets here, but we've only used one of those replies. No, not useful, but still we can store it on A, and that's where we get all replies. And you see, that's the reply to ICMP, and you also have this here, and we're using a private IP or router. That's it, easy peasy. And on top of that, next, oh, where's the mouse? Here it is. Let's do just the same, but with a TCP packet, but not just one. We will use several. So when we receive, you can see, you can have an n number of replies. Just let's do the same. I'm explaining this because when we explain the port scanner, there you know what we're talking about. That's only why, because I know this is a bit boring. But yet, if not, later on it would be a bit more difficult to grasp it. This TCP packet, what do we do next? Instead of saying 1, we say just send and receive, and collect everything that is returned to us. First we run it like this and we see 4 packets have been preserved. Okay, but we want to store all the information, and you see we get 2 variables back. First, information we got, and answers or replies, and this is different. Oh, it's not me, I swear. Well, meanwhile, as it resolves itself, well, internally what it's doing is sending a sniffer trying to correlate information you sent with what actually matches what you've sent. So you might get 40 packets, but only 2 are matched, and that's why it is different. See this? So if you do not store results, that's, well, we do store them in A, but what about B? If we never get a reply, that's the way to tell them apart. Why is this interesting? Because Scapy also helps us script our own software, and that's the way we can know when some information has gotten no answer or reply, and based on that we can react. So I take it for granted that you are experts now, by now, Scapy experts, and let's start working around with PCAP. Are you familiar with them? Please raise your hand. Good, perfect. Let's do the following. Let's generate a PCAP having a Terra connection. Terra and I are in a difficult relationship. I don't like it at all. Well, nothing personal. It's just the way things are. Good. So information coming from Wireshark, we will save it as a PCAP and upload it on Scapy and analyze it. That way you see we can... Oh, it's here. And you can analyze it just as any other physical file that you would have with you. By the way, all the code that it's generated, I was thinking it through, and I will have a GitHub repository created, and then I'll have a Git push. I'm connected to the network, and this is automated, no need to do it at home afterwards. Sniffing? Kind of a circus, isn't it? Great! Because that's the way the net is. Terra, this is going crazy. Good. Terra, it's a very light page, right? Nothing weird. Oh, I don't like it at all. Halt it there. Unless the website crashes, it would be good if it didn't. And then we save the screenshot. Control S. I place it here, otherwise I cannot see it. Where is it? Let's call it Terra Pickup. We have so many formats available, by the default one can do the trick. Save Wireshark, close down my friend here. Let me get out of Scapy because I actually don't know where I am. Here it is. Let me rename it so that it has a more user-friendly name. And back to Scapy. Come on. There we are. What's next? Well, first, load the pickup file. Scapy has a function at a pickup level where you can analyze pickup files, and another one where you can write with DW. So that's W stands for write. Not too difficult, isn't it? I'm not familiar with the syntax. It's a good way of reminding. This is another function which is help giving us information about the function. You see that this is pretty simple, straightforward. Help on function. This is what I want to read. The code is -1 default, so count, sorry, is 1 -1, and this is the pickup file. We want to have the whole pickup file read. The pickup. Funny thing is that we can store it all on one variable and then play around. That's what we are most interested in, actually. Terra pickup, that's the name I've given it, right? Yes. No capture file? What? Sorry? Mistake? Maybe file? What was the name? Terra pickup. No what? It doesn't like the format I used to save it. Even though it should like it, it doesn't. Oh, good. Here. Good. Start again. NG, well, not compatible with Escape, as you see. Takes lots of time to load, and there's a reason. This is a problem with Escape if you don't solve it. All packets are loaded on the memory by default, so if it takes a few megas, maybe not, but there are 600 mega long or big pickups, so it goes on the memory of Escape that can use 800 megas, and you need to take it into account because Escape has to do with the Raspberry Pis, and somehow the system crashes. It's frozen. This is F, Terra pickup, loaded already, and let's look into it. First, summary. It just recasts it. And you see, with DC dump, you get it on screen. We can have a show, which is the same, but with the number of prompts. It might seem silly, but if you don't have an analyzer, it's good to know. We can also draw statistics, F stats, and says, these are the layers I found. And then, when it's down here, can you see it? Good. And then something interesting. That's, I can check out sessions. Why is it different from the number of packets? Well, there's another way of visualizing it, the same as having it all dumped, because TCP is session oriented, and maybe we're interested in pulling together each of the connections by session, by client, whatever. So we might have 4,000 packets, but only 1-2 sessions. If you see this, apparently there are fewer sessions than packets. We can have a length because it's just a dictionary, a Python's dictionary. So 369 sessions there, which is not the same number, I'm sure, as the number of packets, or it shouldn't at least. This is a magical variable where you see all the packets unorganized, over 20,000 as you can see, compared to how many? 369 sessions we had. So you check the difference there. This said, let's analyze the pickup format and see the connections to port 80. There are different ways to do so. We can do it packet by packet, and it will take us longer, but if you come to realize, here, check out this format where we get the information dumped on screen. Here you see the port and then HTTPS because it's sorted, and that's more visible on screen. But if you're at rest, if you run rest, as I've shown you before, sorry, I think I'm making this a bit messier. Sessions. You see a description where the connection goes, and all the associated, the packets that are associated. Since this is our dictionary, it looks through all the dictionary keys leading to port 80. This is pretty straightforward, and it's faster. You don't need to do it packet by packet. So when we are auditing, we need to find our ways around it, because the customers always want it ASAP. So we see requests, packets for port 80, and we will generate a new dictionary. This is just pure Python, by the way. Python, high command, low command. How many? Can you program on Python? Good, no need to explain anything then. If not, this is just a generator that ends up in another Python's dictionary, not more to it. We get all sessions. Scapy is programmed on Python 2. So there is a 4 Python 3. It says it works fine, but I haven't tested. I don't trust it, and so I use version 2. Well, this is silly, but we see dictionaries and the keys, so look for TCP up there. That's it. And lead into, port 80. So I add colon. And this was a student who pointed it out to me, because otherwise there might be a mistake and confuse it with, or mistake it for the IP address. So colon 80 in X. I was missing an in. See? We get all packets that belong to 80. Sounds silly, but when you get lots of traffic and you need to script it like this, as silly as it might seem, it is so handy. It comes in so handy. Variables name, TCP 80. Oh, sorry. I will not build on that. It's a bit absurd. But what I want you to understand is that you can do it packet by packet, packet per packet, playing around, de-stacking layers and everything else. As a conceptual test, or proof of concept. On B, well, you see REST is a list with all packets, and here the only thing I do, well, RP then. This is the second element, and added all layers. So what's beautiful here on Scapy, layer by layer, we can have it indexed or just directly to the layer we want to extract. There you see RP, and like this we already get the RP header. So this is header, so it's good when designing packets and traffic and everything else. And then you see for padding, Scapy shows on padding everything it doesn't understand. All the layers above for which there is no layer actually. If there's no layer, no understanding is available. It means it's not that it's non-existent, but that it doesn't understand it. It's also interested in the piece of information. How we're doing on time? Okay.
I've told you ask you, and if we want to use a sniff function, well, Scapy has a sniff function that can allow us to do plenty of things. And the thing to emphasize in the sniffing function are three. One is the filter, the L filter, which is to filter so it doesn't capture everything, just a normal filter. And the cr0hn. The cr0hn is a pointer to function. Python has no pointers? Yes, there are. like in Java, although people say there aren't. So you can turn a pointer to a function, and that function has to be defined with just one parameter, which is a SCAPI packet that arrives, and each packet that is sniffed is transferred to that function so that the function does whatever it deems appropriate. So we can do more things. So the default function of sniff is to show in the screen, and that's all. But if we want to make it more interesting, we can do it this way. This is silly, but sniff TCP. Sniff filter TCP. If you don't say otherwise, sniff keeps on listening until it finds a control Z. There's no TCP packet because I've done nothing. So everything that I am saying now, we will script later on. We introduce that in the program. So this doesn't stop, and in order to stop it, we say count 500. So it will stop when it gets to 500, but it's going to get nothing because we are not generating TCP traffic. And if we do not need packet, we can also include a timeout, 5 seconds. So whatever happens before will be the condition. And in this case, it would be timeout, probably before count. Okay, so 5 seconds. I'm gonna show you what these PNR parameters for. Do you know what the lambda Python function is? These are declared functions online that do not need the def declaration, which is more formal. And it's very handy for this because in the parameter itself we define the function. What does this mean? We are defining a function, an online function, which accepts a parameter, which is x, which is the packet, and for each incoming packet the only thing it does is to send it back. That's what it shows in the screen, and that's how it works. Of course, there's no packet. Let's generate something. So there's more fun to this. I've opened my friend Terra in another window and see what it does. Each packet arriving, it's only shown, so since I was opening Terra, it shows this in the screen. This is probably images or video, because it's not binary content, then we don't understand it. I'm going to do something that's more interesting within line of command, which is, for instance, to detect or sniff all the DNS searches, whoever does them. Let's presume the network is flat, so all the query is done. And I'm going to do it here. We define the variable. What's good about the SCAPI is that if it works here, we can cut and paste, and we can just execute and it works. So it's good to make tests online, because imagine you're typing the code and then you just cut and paste, then you can see the mistakes more easily. I think it's easier to debug that way. So this is a function that for every arriving packet, in this case of DNS, this is Python syntax. So we're accessing rather than defining a local variable. And you've seen that earlier on we can remove a layer and we can see if there is a layer or not. If you have a list of elements, for instance numbers 1 to 5, and you can say 5 and the list then go to true, and otherwise to say false. It's very easy to, it's a very simple way to do a Boolean check. So these are lists, or behave like lists, and we can say the layer of DNS query is in the packet. If this layer is, then it is a DNS search. So we're ensuring it is a DNS query. I tabulate with spaces. We're just gonna count the queries done. We're gonna use the same sniff, but here we will include the count request. To move as a pointer, you can move the function name, but without the brackets. So we'll write here UDP packet, because obviously DNS runs on UDP to port 53, and we'll change timeout so that I can visit another web page to 25. So we do a ping to google.es. I can't think of Dominion. This one I'm sure exists. Have you ever tried to buy a Dominion? So we've received 3 packets, but what we're interested in is checking that it has this variable. If it's queries DNS. That's simple. There's no more to it. Now I'm going to tell you a way of doing flooding with SCAPI, which is a massive flooding of information package to destination. It's usually to do evil. Because SCAPI was done on Python, and Python doesn't have a great yield. Do you know the TCP replay? It's a program on C which pre-processes all information to be sent. It has it on a network format and puts it through the cable straight away, through the interface, and it has an incredibly high send rate. We could do it with 4 send information, but you will not get a flooding. So we use the wrapper, which is in SCAPI, because it is CPRP, it runs below. So send P, and send P fast, which only uses this underneath. I'm gonna do this and a couple more things, and then I'll start typing code, don't worry. So X is the packets, even packets per second, megas per second if you want real time, or loop if you want it to send straight away. So there are many options to do good things. It's all very healthy. So we're gonna build a number of packets, and we're going to build the list of packets, IP and TCP, to be sent. So I'm going to show you, and I linked this with the fuzzing area to see how easy it is to get a list of packets with just one line. Look at this. Packet PKT LST IP We don't want to be arrested on our way out, so ICMP has a parameter in the header which is ID, and this is the crux of the matter. We can pass rather than identifier to a list, but we have it in the header of ICMP. So when we write to SCAPI 400 ID, it generates 400 different IDs, packets with their own ID, and if we have that in IP as well, those 400 that we have by the 400 that we generate in ICMP. We're going to send only 100 packets. So there are plenty of combinations, and if we send it straightforward, normal, it sends 100, which are the ones we've requested to be built. And then send P fast, but we want to be bad, we do the fast function, and it looks as though it goes slower because it answers more slowly, but it's not that it's going more slowly. It's getting that information, it's calling the program of the system in command line, and then when that's over, it sends it back. But what's interesting for us is that information should be sent very fast, not so much that it comes back very fast. But here there are only 100 packets. Let's add a couple of zeros. 10,000. If there's a DOS in 127, we're going to have a laugh. When it stays longer, it's because it generated these 100,000 packets. But what's interesting is not so much in how fast it answers to us, but how fast it's taken to send them. Maybe I've overdone it a bit. My mouse still here. Good. Look how funny. There's no more memory available. Do you remember what I said at the beginning? That if we generate all the packets, they load them in memory, and that's a problem of what we've done. But I want to do these nasty things. Then how do I do it? Well, don't worry, we'll find a way out. This is pure Python syntaxes. If rather than rather than square brackets, we include the sign for memory generator, you save loading all of that into memory. And I've just remembered that you cannot use that for the parameter. We don't have to do this otherwise. I'm going to generate it so you can see, and then I move on to the code, because otherwise we won't have time. So 1,000 packets in 0.0 seconds. So it's been sent very quickly. If we had to do the direct through SCAPI, it would take a lot longer. So I think that's all I wanted to. Oh yes, the fuzzing. SCAPI was invented to do all these things, and it has a function to generate random information. For instance, the rand IP, and each time you call it, it generates a random and valid IP. And why is that found? Well, if you want to send this with random information each time, we can use that. And randmac is also fun. All parameters, randmac valid and random. If you want a port, it doesn't make sense to have a rand port, but it makes sense to use this, yes. But I could use the random function from Python, yes. But we have to limit this with a module, because otherwise it will crash. Okay, that's it. I'm not going to go more into this. It's just that combining both things with the parameters and everything else we can play, that's all you need to know. So I'm going to open the ID. Whatever happens, I use CyberCamp because I like it and because I have the license, both things. What am I going to do then? New project. We're going to do it in Python 2.7. Do you know what a virtual M is? Raise your hands, please. The virtual M in Python. It's a sandbox. You generate a virtual environment for the Python interpreter so that all of the dependencies that you want to install stay just in that virtual M and they do not mess up the rest of the system. And on top of that, it has the advantage that you can install dependencies without being root. So you can have the two good things. You can have it both ways. So since I've this installed already, all the dependencies, it's come to this screen to say that I select directory. I want to have it here so you can see. So we choose this directory, there's nothing, obviously. So what are we going to do? To make this more fun, we're going to implement an ARP plot. You know what this is? And the final goal is to crash a switch. You know that it takes all the max in the CAM, and if it's not properly implemented, it becomes like a hub again. And DHCP starvation, what it does here is we start asking for IPs to the DHCP until it runs out of them and it can no longer meet the legitimate requests. You see, there are a bunch of macros because I use this quite often. We create the function. And why do I use this syntax? It's in Python. Very simple, because like in all programs, the M function is the main one, and Python by default executes everything. And if we don't say that this is like a log variable, only when I am executing the command line, then do you execute this. So that's why we close this here, and this is just good practice. This I can assess that when my summarize list I take less time. So we're gonna take you guys know how DHCP works. You make a request, it's returned. You just go in and make the request. That's all. To play with Scapy, what we have to do. Scapy all import. We need the header, ether, the IP header, UDP, DHCP, which is the new protocol. It used to be called bootp. That's why it has a part of bootp. So that's why I import it. So what we're going to do in terms of scripting is to start generating everything. I write the origin from where? From any Mac, because we want to behave badly. You cannot. We obviously import as well RANMAC. Another important thing is that when we are scripting, we can separate everything by layer, and then we can put them together with just a slash or with the division symbol. And when you're writing, it's a lot more convenient. And this is because the protocol says that's how you should do it. Have I written 5.5? And you send it to broadcast? I've made a mistake. I've changed the port. So boot P. And what information is there in boot P? Sorry, I'm on the wrong line. So we're saying what's the name of our host because it needs it. So rather than doing the import RAM in Python, we do it this way because it's simpler. It will generate a host name with a 12 character length, run string. I don't know if you can see the screen, but I can't really see. And finally the DHCP. This syntax is not so good. We have to say, okay, we're building the packet. What do you want them to send? Well, I want you to send a type of message. And then send that and nothing else. So what we do is we build the packet little by little, UDP, boot P, and DHCP, and I add what we've been doing so far. It's going to give me a failure because I haven't imported the send P function. So we go to the terminal, I get out of here. Haven't typed the E. Let's see if I can see a bit better. That's why I wanted a monitor. Okay. Why? Because and there it is. We've seen it's set as the one packet. If you want to see it, we can go to Warsaw and filter. And here you see the name is also boot P. But I don't want to take more time with this, so what's really important here? What should we do now to do the DOS? It's as simple as that. For X, X range 10,000 packets. So it's 10,000 requests for DHCP, and every time it's sent, it generates all of that randomly. I'm gonna stop it in case the server is protected. So with this you can really do away with any DHCP. If you want to go to your company, since I'm going to upload this, you just cut and paste and you can go have a coffee. So having done this, I'm going to do the ARP flood. I've said that I was going to do type one attack and then the other one. I'm going to do the ARP flood. I'll cut and paste so I can really have time to show the fun part of the demo. So this I'm gonna keep. I won't keep this, and I will keep this. So to get the ARP flood, we have to generate a lot of ARP requests, so the switch learns this, and that is there's a software that does that, the Mako, does the work for you in just about 3 seconds. So it's the same, but doing it with Scapy. So we have our Ethernet header, and the protocol says this has to be otherwise. This has to be the broadcast MAC. We add ARP here. So what operation do we want to do with ARP? It's called CR0hn. We don't care about the IP as long as we do damage. And destination, we don't care who receives the packet. So we have to have the hardware addresses, and by that we mean MAC. Run MAC. Have I imported the run IP? No. Okay. I've sent one packet, just one, like I did before. And this you have to send with send P because it works in layer 2. Ether ARP. Okay, I sent one packet, and just like before in Nasty, it's just as simple as putting this in a loop. Because I don't know if switches are securitized. I'm gonna cut it here. So we can use this in a very silly way, rather than sending packet by packet. And this is as good for this case as for the previous one. In the previous one, the DHCP, I'd rather send it little by little, but here we can set everything simultaneously. And for that you pre-generate all the packet list, and then you set everything together. That's all. This is also up to the network, and we can even combine them. We could have 40 of them. So we have another attack in code, and this works in pretty much every place you can think of. So we're going to generate now a port scanner, mono-thread and multi-thread. Just to do it faster, because otherwise I'm going to take a lot longer. So what do we need for the mono-thread port scanner? We will just generate the typical structure that you've already seen, name, etc. Main. We want to know open port. We will store it this way because it's more convenient with a global variable.
Esto me ha pasado toda la mañana que leí.
You see, it keeps freezing. Okay, I need to close it down and reopen it. Is it open? On it. RP flat. So we are writing code on Python 2. Let's embellish it. Open ports. Show me results. This will be just some screens and that's all. Just briefly, then we can tune it up as much as we want, but we will analyze ports 78 to 81. That's the port list. So analyze port. It is a function that we can create, and since it will have no parameter because we will not have the host, the prompt is just like this. We create the function. Good. What are the parameters here? Host and port. So we need to start using escape here because we will be using the ask functions that I said before. We will send and receive answers to know whether the port is open. SR1 will do it packet per packet. This would be it. Host is destination, TCP, LD port, that's the port. We are going to say we don't want a pop screen, but then Escape will do whatever it wants. But it has to be 02. 200 milliseconds because you get filtering packets on the other side and could take, I think, indefinitely, probably not because there's a sniffer going on inside. If we have some items back, and if the header TCP is pressed, this is the syntax as we've used so far, is it not? And so we will have access to the TCP header, and we will make sure that the flags are there. Let's see if 18 is active, is on. Yeah, when converting from hexadecimal to decimal is a SYN-DCK. That is a three-way communication. What it means in a three-way communication. If open, okay, simple as adding port. Why is this like this? Res is not. Oh, good. It's so let's write it down here to see the ports. See open ports. Good. Just this blank spaces is just a choice of mine. and another print in the end to have a blank prompt. So it is a port scanning on Google, right? Yes, Google. Port scanner, Python. Analyze, okay. Column. Function works. Look, red. We haven't added the escapee headers. SR1. Nothing else, right? So verbose false. So SR1. Thank you very much. I could not see it. Port 80. Google only has port 80. Simple as that. Let's change the scanner and have it multi-thread. Let me copy paste the very same file because we will be reusing it all more or less. So what are we going to do? First, define concurrence. The mouse is giving me so much trouble. This one. You know, on Python the threads is just a lie. It's just half true. Concurrent but not simultaneous, which are two different terms, but that's something else entirely. How will we stop it? Simple. So check this out. The port analysis function won't go through many changes, but we need to link it in a way for it to be concurrent. So what shall we do? We will create as many threads as concurrent says. So one thread per port. So if you use threads on Python, you can inherit from the thread type, which is a bit messy. For larger tasks can work, but here what we want to do, well, no need for that. But when we use the pointer on the function analyze port and the parameters like this, it would be a tuple, which means that needs to end in a comma. That's a type of data on Python. Google.com, did I type it correctly? That's the port. Change the name, and what we do next, we create a thread list because, well, Python, well, sends them but doesn't wait for them to finish. They say the threads are still on memory, so there you need to wait manually. You need to have the thread list and say, are you done? Are you done? Are you all done? Good, so let's all die in a fashionable way. So next we add the thread to the list and start it. Now we hold, or we add hold as we said. As simple as that, and it works for us. We can run it only a few ports, and so we will have a good outcome. But actually here we are not using concurrence 5. I have not regulated that. So if we want to analyze 4,000 ports, it will start 4,000 threads, and it will be messy, as you can picture. So let's use a light, a traffic light. It is just concurrent programming, what we have here. But that's what we're going to do. We define a traffic light. value while concurrency. So, whenever we start a traffic light, it has to decrease by 1. Someone needs to release it at some point because otherwise we'll have interblocking. So, the parameter to the function will be the traffic light, so the function itself releases the traffic light. This is just concurrent programming. On paper, unless I've missed something, if we run it now, it would be a multi-thread execution. But it works fast, we don't notice it. But what about 800? And we are at some debugging. Analyzing port. You see it is concurrent. With Control-C, threads will not die out. As I say, Python won't release them, only when it seems appropriate to it. It seems that being released this case. We have a multi-thread analyzer on Python, and no embellishment, or a little embellishment. We could do it even in a simpler way. 23 minutes, that's what I have left. Done? Let's try to make these tools a bit more professional. So they are not a target script anymore, but they need to have a tool, syntaxes and structures, some prompts and parameters that can be sent. They need to be scalable, reusable. When I say scalable, what I mean is that you can go back to it at some given point and reuse it, not the other types of scalability. So last year, I came here to explain OMSTD and other tool creations methodologies. I will not dwell on that, but those are best practices. As a consequence of that, I created STB, which is Security Tool Builder, which just basically creates the skeleton, the structure, and lying beneath. So you open it on ID and it works. And you've got most of the tiresome work done, set up and everything else is already there. And when you create it like this, you know, on Python, you need to have a bit insert for library installation. So like this, you have the tool built in a way that you can upload it on pip. You can have PSDs upload, and it uploads it directly because you can have it installed with pip install. It's just like that. It's pretty common. By default, it is a bit tiresome. Actually, when I get bored and I start writing code, well, I got tired. So tired that I built distraction myself. I'm checking out this browser where I have another window open. I was going to show you the project web, but, well, yes, I'll do. Because if you type STB on Google, you get lots of crap. It's been split into two. STB, Security Tool Builder, and STT, which is the pattern, the structure. So this is how it is run. This is funny, isn't it? So at STB, when you install it, so it pit install STB. There are a few questions, name for the tool, an author, everything else. And you get the skeleton, dynamic skeleton, where it belongs, URL. Actually, if we want to use Python 2 and 3, you get a few structures generated to use it one way or the other. So, not defined, what does it mean? Walk-on, it's a virtual manager, so you can have many virtual ends and handle it with Walk-on and switch from one to the next. I have one for my tool to have all dependencies installed, and I use this one because I know it works. And there you can also see what's the virtual end you are in. That's why it's so positive about it, because if you have a library like this, it happens what just happened, you find a discrepancy and maybe things do not work. So, a few questions too. What are we going to do? What were we going to do? Because I had it all planned. So, this will be the format. Beautiful, isn't it? Name will be CyberCamp. Cyber is fashionable, isn't it? Description, I don't care. Longer description, don't care either. I don't know, author, hoo-ha. Email, IGMO. Oh, sorry, the same. And project version. And supported for Python 2. Yes, it's free of charge. Python 3, yes, free of charge as well. So generated this way. We get a directory with the structure for tool generation. So next, on pie chart, I'll explain open directory. I will open that directory. We just generate it. Good. 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 So see what's generated. We get it all here. README, similar structure with the tool name you've specified, the logo, which I think is the default STD logo, but it can all be changed, and you see the structure of versions and everything else set up as well. And even what you see here already built, the author, which I made it up, but yet you can see it's already there. License just the same. You see the author, I stated this, and this is for project name, but you can of course state what you want, and chain block as well. This is structure for the tool posting, PPs and everything else as part of cybersecurity.lib. That's where you get the code per se. And to see that it runs, you see this is the structure, main code, package name. Here, well, you do not touch this, okay? This is mind-blowing on Python. It took me years to learn it. You can import libraries and also see what are the prompts. What's funny here is that you have the regular CLA, but you can publish it, and then you can say from cyberscam dot whatever, and it's used as part of an API. In order to use both things, you have to do this, but no need to touch it. We don't care about that. And there we see a basic prompt and the target that it says, and some help, brief help as well. So here, if we want to run it, we need to go into that directory. Does nothing. Tool is ready to say start or reboot. Does nothing. And there you have the default prompt. Simple, right? 15 minutes left. Ooh. This is the mono thread scanner. It's simpler. You see how we adjust it, and then I explain a few more things that I would like to show to you because I don't have time to write it all down. What will we do? Well, you see, I have a shortcut to double lines, duplicate lines. -P, meaning that's the port, because this is a port scanner. So I want you to scan these ports for me. To make it easier, this will be AP1. So source and destination ports. Not too complicated though. Or rather, first an initial and end port. And I'm afraid I cannot see what I'm typing myself. Default value removed. Before moving on, let me explain what we have here. Well, we won't be using this. This structure gives you data which has a global structure on which we can send all the parameters on the prompt. Why is that? Why do we have this structure? Well, if we set parameters to the software today, but we want to add a few more tomorrow, this needs to be an option. If we were to have to change it function by function, where parameters are accepted, we would need to change lots of code. If we just run the structure like this, we will add a parameter to the structure, but no need to change the function statement or functions themselves, etc. That's what it's done with the large tools. And if we want to run it as a library, this would be a class, and we will be used on the cr0hn tool. And the same for result. It is saved in a different structure and has some default information, starting our feed and status, and see if it's joined together or not. That way it can be part of an API or part of a prompt and see what's the structure and how to interpret it. There's another file called API, which what we do is, instead of, well, we are building the tool as if our own tool was using our own API. It might be a bit recurrent, but if we do so, it is defined in a given way, as if it were API oriented. And so we have a nice looking prompt, but using our own API. I don't know if I'm clear. We just define it all. And that's why we have a file that is .api, changing entry or access to the function. We can have console or running, or just run the program. And here we add whatever we want to do. Simple as that. And when you have console running, you see the screen both for Python 2 and Python 3, and it calls the API function. That's what I'm saying. This is just nuance. We also have documented, generated by SFIS, or this lib library packet for whatever we want. So let's say we want a file where we have the scanner, copy paste what we had already done, change window, and monothread I said it would be. So this is the analyzer. I'll paste it backwards again, copy import. Good. Good. Before we forget it, we have a application dependency here, so we go to requirement and we add it. See, there are a few default dependencies, for example, screen color, 6 for Python 3, whatever. Here, we have it. Scanner. The call function here. Not to make it, in order not to make it any more complicated, just do it like this. This is the API function. This is what's actually run. It all goes through this. In order to simplify it, our code goes here. So config, and it's properly documented. It is a global parameter in the structure I showed you before. So we know this is the prompt. We know there is this parameter port init and port fin, initial and final. So global parameter by default gets the prompt, whatever we wrote in there, and the text and variable name gives us a property with the very same name, so we know how to do it. It's simple. As we know that config comes from that structure, and with what I've just said, oh, I cannot see anything. I'm typing port any config port end. I don't want any errors, but I will get them because it's just text line. This function, well, we've imported it so it doesn't know it. So all the way up, let's zoom out, import. We always need to have relative input so that it's portable. So analyze port. A few more things and differences. Well, no, not there. We want here, this is a function called target, right? So by default, you can write down 140 targets, which means that you get a target list. Now to simplify it, we will just choose first one. And on paper, and if it works, and we live in the world of wonders, this should work just similarly. Only difference is that we don't see the open ports on screen because we have not specified that. What do we do? Slight modifications needed because export was a global variable, right? Since we don't want it, because whenever we can avoid global parameters, all the better. So each port needs to be analyzed, and there we need a reply, whether it's open or closed. Instead of this, return true. I'm typing blindly. Return fast. This could work either way, I'm afraid. Good. There we go. API, that's what we're working on, and what do we do next? So the result info, we will not use this structure anymore now to make it any more complicated than it is already. So results stored here. So this is true. What do we do? Add results. Add port we are scanning. And return me results. We don't show it on screen because if we did so, it wouldn't be an API anymore. An API won't show you anything on the screen by definition. And that's where we get our screen info. Or info on the screen, rather. And that's what we did before. That's B, and just following the same line. That's syntaxes for Python 2 and 3, both. TCP X. Gonna get a stiff neck here. No module name cr0hn was found. Has to do with virtual ends. Deactivate. Trump caller. Oh. Since I've been having problems with virtual ends and everything else, it's quite a mess up. I'm gonna do what you said. Good. That's the syntax is to grab a file and have all the requirements within the packet. That's all there is to it. Not allowed. I'll do this. I don't like it, but if not, I won't finish it up. Term color, everything else. No colors, I'm afraid. Same here. Good. Good. It starts but doesn't end, or at least we are not told it does. Why is that? Because we probably have some exception at some point. Why? Well, maybe we haven't set the source or destination ports. 79P281. 81. Another exception. Which one would this be? Well, analyze port has no source or destination port. Sorry, initial or final port. 4 minutes left. Okay, let's do the following. I've removed all exceptions. This should not be done, but at least we can say it. cr0hn google.com. So it doesn't like Google. cr0hn Google. Host and just one port. Yes, you're right. You're so very right. Usually it takes shorter when you are not about to get a stiff neck in the process. So let's change source and destination ports. Oh, damn it. My own bad. No configure anything. X. Yes, you were right, Pa. Port 80. There we go. Have a second, you see, but like this, where am I? We can have a Python setup. That's the way we generate the packet. And so we can have it on Pi. If we were to run a register and upload, it will upload it directly, but I will not do it because I'm not uploading this crap here. And then finally, since I don't have time to write it, because I only have 2 minutes left, I'm showing you code I had ready with me just in case, as the coward I could be, because I knew things could fail, and they did. And that's brute force and web and everything else. Okay, here, otherwise you cannot see it. Good. I have this project, I use the same STB. New window, because you see, changing wonders, it's driving me crazy. Forget about pickup because I've been reusing code. So here you see word list ratio, matching match percentage. Okay, let me explain. You would get a target HTTP column crashsite.com, and there I would get a dictionary, which is FastDB project. I probably you heard about it. It has words of everything, passwords, and most used packs, Tomcat, IS, forgotten packets, everything. I downloaded it, used it as a directory. You have the master and predictable things. Everything falls in there. We go for brute force, whatever you choose. Here you see extensions, not a good example, but what about directories? Include images. There we upload the file, we take the URL, we paste it, and send requests to test whether it exists. That's a brute force. Oh, evil sculling. And since we understand that it's all gone through prompts, as you see there, or this is the kind that runs like this. This is the base path, which just defines the initial path where dictionaries are located. That's the prefix. And this is the main function here. Good, so config is information coming from the prompt, as we've done so far. These are the results, and those are the paths we've uncovered. And we add the extension on the word list. It's a bit messy. And we generate the path route of the file we want to upload, the dictionary. We open it with, that's Python syntaxes. Anything inside with means that as you leave, it closes down every window. And in the word list element, we create the lists, so path lists through the file. And we have a random error page generated. Why? Because if it's properly implemented, the server will have a default error site or page, and it will not return us a 404 but a 200. In order to test such situation, we generate a chunk of code that will give us a defect or default error page that is random. So this is a random chain, and we add URL and everything until we have a fully random chain. Then we send a request. It comes to us with that URL, and you get the content and the status quo of HDL. And so I need to have the content of that random page. So that was the status code, not quo, sorry. And so we start going through the list of elements, what we've uploaded from the file. And the only thing here is we paste to the target each of the elements.
Each directory that we want to discover, we make the request with the function that I've shown you earlier on. It returns the HTTP code and content. And the good situation, if it's at 200, that is the assist page. But smart, we want to introduce intelligence, yes, no. If we do not want to, and it's given back to 100, means that the directory we're looking for exists. If we want to introduce intelligence, then we use this function. And what does it do? That we have set up here. In Python, there is a native library, the bindiff, which is a comparator of text chains. And because it's native, you don't need to install anything else, so why not use it? And this is how you use it. If we may want to use a prefix or a rule when it comes to the comparison procedure, but in this case we're saying line-to-line comparison, content 1, content 2 that we want to compare. So here we will have an error page in the one we've just compared. And this class, because this is a class and it has a method, one is the ratio, quick ratio, and I can't remember the other one, but what it does usually is distinguishes by the time it would take to calculate the difference. So what we're looking for is a ratio from 0 to 1, a percentage value, to know how similar are both contents. That's the goal, that's the ratio. So we go back here, And what are we saying? If we want a ratio, an error margin, so that it's similar, or they should be dissimilar of at least X. So at least 60% different, so that I consider that these are two different web pages. And why 60? Well, this is just an empirical value. Imagine it's a personalized page in which the right column and the left column, etc., the structure is very similar, but what it dumps, the content is very different. So experience tells me that it's good to have a ratio between 55-75% depending on the site, to be able to distinguish what's a page from another. And as it depends on the site, the matching error allows you to specify the margin, the error margin that you want to have. So if you think that it's sufficiently dissimilar, we add it to the list as having discovered a new URL. And that's all. We generate the result, and we've done like we've done before. We go to the API, which is where you would call it, and then we receive the results and we show them in the screen, or whichever way we want. Okay, but note, and what's interesting about this, and beyond the ratio and all that, which is just about having that happy idea again. What's interesting is that this tool, with this structure and the way we have it here, the ping install, we have it, and we have it. So it's incredibly easy to install. And in fact, in Bit, I think the hacking tool, there are one or two, and one is mine because I uploaded, because by using this, and Scapy is also there, but it's not very well installed, but there are very few others. And why? Because usually when you program well and you use your own stuff for libraries, but the ones who do hacking tools don't bother to do all these things. So we try to bring together both the worlds and making it easier, because it's quite a pain in the neck. So try to make it as useful and easy as possible. And I did this for myself because I wanted it to be useful and easy for me, and in fact I use it daily. It's a pity that I cannot show you how to use Nmap from Python. And in this case, we're only just using a library that's already there, that has the results of the Nmap, and with the same structure, we say, tell me where the Nmap file is, I load it, I use the library, and I use filters, whichever way I think fit. But I didn't think it would take so long. The plugins system that I have no time to show you properly, but I have a silly example. You can implement this type of system in many different ways. Dynamic load, I leave it in a directory, and I use the common contract and all of that. Or we can do it in a very simple way, which is as simple as what I've done here. We generate not a directory, but a packet with plugins. We separate what we want to have in each packet. So we generate sub-packets with different concepts, network attacks, web attacks, etc. And within them, a pi point for each plugin. This is very simple, as I'm saying. So it's really just sort of barely plugins. In the command line, we have a config property that here is attack, but we could say -p plugin, whatever we want. So what does this do? You would just receive one value, whichever, but that value would be the plugin that we want to use. So if we write CDP overflow or CDP attack 2, so we import the corresponding file .py that corresponds, and then we execute And this is important. We use the same global configuration that we've used for everything else, and we want, because this is a very simple method, but in this way if we want to add headers or parameters only for that plugin, we can introduce that directly in the command line, and you receive each plugin. So I send you everything, and each plugin collects the information they need. And why this run attack? Well, just because it's convenient. So our own agreement, or we define that all plugins have an entry function that I've called run attack. And why? Because then you know that whatever you import in the path, it doesn't matter which plugin I import, I will always be importing the same function. And so they're all called the same. And that makes it immensely simpler. That's the only reason. So this is a very silly system that's very useful to do a rudimentary plugin system. And I think that's it. I'm going to show you the rest of the slides. This I've already explained. And there's nothing else. So that's what I wanted to tell you. I'm sorry we didn't have time to tell you as much as I wanted to tell you, but that's all.
Preguntas, dudas.
Questions? Do you have a roaming mic for this boy here?
Ostras, qué bien.
Bueno, primero enhorabuena por la charla.
First of all, congratulations for the talk. It was great. What we have not been able to see are examples of the examples of of what we have not seen. Will there be available in the repository? Yes. I brought the whole directory, and I will upload everything. That will be available. That's all. Thank you. I was going to see you can have the slides as well, but they're really not worth much. That's all? Come on, don't be chickens. Okay, thanks.